Here we use the Newton's law of cooling to determine the temperature of the object at any time t, and it is given by this equation: T of t equals Ts plus To minus Ts e raised to the power of negative kT. This T of t is the temperature of the object at any time t, and this Ts is the surrounding temperature. To is the initial temperature of the object, and t is the time, k is the constant to be determined. So let's plug in the given information to determine the value of k first. We are given that the initial temperature of the gelatin salad is 43 degree Fahrenheit. This is being taken from refrigerator and put into the room with the room temperature 68 degree Fahrenheit. And after 12 minutes, the temperature changes to 55 degree Fahrenheit. So we see that when T equal to 12, the temperature of the gelatin salad is 55 degree Fahrenheit. So let's plug in this information into this equation first so that we determine the constant K. I'm going to plug in T of t equals 55, and this equals Ts is 68 plus T0 or To is the initial temperature of the object, which is 43 minus Ts is 68, e raised to the power of negative k, and t equals 12. That is, after 12 minutes, the temperature of the salad is 55 degree Fahrenheit. Now let's solve this equation to determine the value of k. First, I subtract 68 from both sides. That is, 55 minus 68 equals negative 13. And this equals, we have to subtract this. That is, 43 minus 68 equals negative 25. E raised to the power of negative 12k. Now we can cancel this negative. That is, if we divide both sides by negative 1, these negatives will become cancelled. And also divide both sides by 25, leaving as 13 over 25. And this equals e raised to the power of negative 12k. Now let's apply natural logarithm to both sides so that we can solve for k. And so we get natural logarithm of 13 over 25, and this equals natural logarithm of e raised to the power of negative 12k. Now using the power rule of natural logarithm, we can bring this exponent in front, and so this becomes negative 12k times natural logarithm of e equals, on the left side we have natural logarithm of 13 over 25. We know the value of natural logarithm of e equals 1. So therefore we can remove this from the equation. And solving for k, we get k equals natural logarithm of 13 over 25. And this has to be divided by negative 12. And so when we plug this expression into the calculator, we get approximately 0.05449. This is the value of k that we have determined. We now determine the temperature of the gelatin salad after 20 minutes. So we plug in t equals 20 into this equation, and also plug in the value of k we have just determined. So therefore the temperature of gelatin salad after 20 minutes, and this equals Ts is 68 plus To is temperature of the object 43 minus Ts is again 68 times e raised to the power of negative. We replace k by 0.05499, and also replace t by 20, and so this equals 68 plus 43 minus 68 equals negative 25. So this is negative 25 e raised to the power of this quantity. This is 0.05449 and not 99. So when we multiply 0.05449 times 20, we get 1.0898. So it is negative 1.0898. And so we can simplify this expression, numerical expression, by plugging into the calculator. And when we do that, we get 59.6, and this is approximately 60 degree Fahrenheit. And so this is the temperature of the gelatin salad after 20 minutes.